Hello there, this is exercise 10C for A-level maths, year 12 A-level maths to be precise. We're looking at three special angles that you need for A-level maths for sine, cos and tan. And in particular, the kind of angles we're looking for are the angles that you saw at GCSE. So we need to know the angles 30, 45 and 60. And I suppose you could frame around that 0 degrees and 90 degrees as well. But these angles never used to be on the GCSE at all, and they were, so with sine, cos, and tan, that is. And then suddenly at GCSE, it's recently, for the last couple of years at least, it's been the case that you do have to know them, and you're meant to know the sine, the cos, and the tan for these angles. So you might, for instance, have learnt a table. That's meant to say cos. And tan for all these different things. And there's ways to learn that. But I suppose what we're doing here today is we're going to remind you of them, and we're going to show you why they are what they are, which is slightly different from GCSE. We just got told them. So before we do that, a bit of SOHCAHTOA, a bit of finding the angles. So just remind you, personally, when I was doing this with year 12s, year 11s in the past, I would always label the sides. So this would be the hypotenuse, and this would be, because it's next to the angle, the adjacent. And then this one, I suppose it's the hypotenuse. I'm going to label all three pictures. And this one's opposite. That's okay. And what's this one? Well, I've got the opposite again here. And I've got the adjacent down here. So if I was doing this first example, I would be saying to myself, I've got the adjacent and the hypotenuse, and it's clearly going to be the cosine. So cos of the angle, which is what I'm trying to find, equals 8/12. And of course, this is relatively straightforward, isn't it? This is no more than what you saw at GCSE. And probably easier because it's no wordy questions and context and stuff. So obviously what you then do is you get your calculator out, and you're going to have to type in, I don't know what's wrong with my pen today, inverse cos of 8/12. And I'll do that now. The inverse cos, make sure you're in degrees, because if you're not, you're going to get dodgy answers. And I get 48, well, it's never going to be exact, I suppose. 48.2. I'm going to round to three significant figures. Okay, and you have to do that for all three examples. So I'd suggest you pause the video, do the other two, and then I will start the video again. Hello again, and just for reference, I've actually changed my pen, so who knows, it might even be a bit more precise this time round. So look, you were asked to do two more questions. These were my three answers. 48.2 is what I got, and hopefully you got 53.1 and 56.3 on this one. This one should have been the inverse sine that you do on this one. And this one presumably is the inverse tan. It looks like it's the inverse tan. So hopefully you got those three answers, no more than GCSE. Let's go on to the main part of the lesson for today. Three special angles. It says it can be very useful to remember the trig ratios for these three special angles. And it's certainly the case that you're meant to know them. And the thing is, we can use some basic trig tricks, I suppose, on some special triangles. And the special triangle I'm going to start with is an equilateral triangle. This equilateral triangle, by definition, therefore, has 60 degrees in each corner. And since they are it's an equilateral triangle, I also know the sides are equal. I can make them equal to anything I want. Now, a convenient length, weirdly, is to say they're all 2. Because what I'm going to do with this is I'm going to split it right down the middle. And when I split it right down the middle, you'll see essentially, then I can say each side is 1. So that 60 splits into 2 with a right-angled perpendicular being drawn from it. And that gives me therefore 30 degrees on each side and 1 on each side. That's why I wanted to call it 2 to start with. And now I've got that, really I don't care about the right-hand side. I'm just going to draw that left-hand side of the triangle. And I'm going to use perhaps a bit of Pythagoras as well, because the thing about Pythagoras is it will let me see what that other side is going to be. And you probably will recall Pythagoras being this a squared plus b squared equals c squared trick. Or you might have even remembered that if you want to find the side here, like this is like the height of this triangle, I can think, oh, I should have put a square there. I could write h squared in this case is 2 squared. And it becomes a minus when I move that over, minus the 1 squared. And I reckon that is root 3 there for h, because obviously this is 3. And I'm going to have to square root it. And so now I know that is root 3. I'm able to write down some interesting things almost straight away. So here we go. I mean, this is a rehash of what I just had. But what you'll notice then is if, for instance, I want to find, and it says here sine of 60 or sine of 30. I mean, I can essentially use this triangle with my 3 sides to do it. So sine of 60, of course, I'm just going to write SOHCAHTOA at the top again. Now, sine of 60, I've just got to make sure I pick the right sides and then everything will work. Sine of 60 has opposite that way. So it's opposite of our hypotenuse. That looks like root 3 over 2 to me. You can just write these down straight away. Now, what about cos of 60? Now, cos of 60 is adjacent over hypotenuse. That's 1 over 2, or half, I suppose. And what does tan of 60 give me? Tan of 60 is the opposite over the adjacent, root 3 over 1. Now, root 3 over 1 works, but actually it's better written as root 3, I suppose. And we can do the same thing with sine of 30. Now, sine of 30 is slightly different, as much that now I'm looking at that angle I'm finding, and therefore the opposite now is the 1. So that for this one would be the opposite. And this one here now, the root 3 would be the adjacent. The hypotenuse won't change. So again, sine of 30 is opposite of a hypotenuse, but now because opposite the 30 is a 1, becomes 1 over 2. And you'll notice it's just this one, just the other way around. My cos, which is adjacent to hypotenuse, is now root 3 over 2, because this now is the adjacent here. Root, that was not a very good root, was it? Root 3 over 2. And what was the tan 30 is again opposite over adjacent. I nearly said opposite over hypotenuse. Opposite over adjacent. So that's 1 over root 3, which again is true, but you can better write that. And usually that's better written. If you type that into your calculator, you get root 3 over 3. And that's the nicer way. If you play around with the surds, it all works out nicely. Now that's then given us, if you like, 6 different facts that we're meant to know. Sine 60, cos 60, tan 60, sine 30, cos 30, tan 30. These are 6 facts that we're meant to know about. So we can do a similar thing for 45 degrees. Let's have a look at that now. We start off needing a triangle, and this time it's a right angle triangle. In fact, there's a special right angle triangle. It's got 45 degrees in each corner. I suppose that makes it an isosceles triangle, but it makes it a right angled isosceles triangle. Again, we can set the sides into anything we want, and this time we like the sides to be 1. And then by Pythagoras, again, we can work out this missing side, and it doesn't surprise you to quickly learn that the missing side is root 2. And we now need to know these 3 trig ratios, and we do the same thing. We say sine 45. Now, just use this one. You could use either one because they're both 45, but this one does the job perfectly well. Using SOHCAHTOA, you get opposite over hypotenuse, 1 over root 2. Now, 1 over root 2 is again best written as root 2 over 2, because that's, people prefer it with a proper number on the bottom, basically. Cos 45 is the adjacent over root 2, which is, you'll notice, exactly the same thing. And that's worth knowing as well. Again, my pen did funny things there. It's root 2 over 2. And the last one is just 1 over 1, opposite over adjacent. So 1 over 1 does just become 1. Now, the last thing I want to do with you here is to look at how to find, I suppose, related angles and sine, cos, and tan of them without you having to use a calculator. And although you, let's face it, if it came up in an exam, what sine of 120, we're probably just going to type it into the calculator. What tends to happen is you sometimes see results, and it's useful to know, that might be sine 120, or that might be a sine of 60, or something like this. And knowing what you're looking out for, perhaps root 3 over 2 and root 2 over 2 and root 3s, all these answers that we've had, it's useful knowing them. So don't dismiss this because it's tempting to do so because you think, oh, I'm just going to do it on the calculator. It turns out it's quite a useful piece of knowledge. No, we're going to do this using the cast diagram, which I've hinted at before. And it says sine 120. Now, the thing about sine 120, I want you to be aware of, when we do the cast diagram, this is 0, this is 90, and you go round in this anti-clockwise direction. This is 180, this is 270, and eventually you get back to 360. So bear that in mind. Now where 120 goes, and it goes round, oh, it goes, that's 90. I suppose it goes up to about there. And I suppose you can say to yourself, well, if that's 90, 120, I reckon there's 60 degrees left. And you always try to use the angle to the horizontal, which is why I've highlighted this is 60. Now, the mere fact that it is 60, and I want sine, I say to myself, what is sine 60? I need to know what sine 60 is. And sine 60, I know, is root 3 over 2. We just saw that. Now, the next thing we say is we write cast on this. And you'll notice the sign S here is positive here. So this is quite simply just equal to sine of 60. And that's equal to root 3 over 2. So I'm going to do this a few times where I'm just going to use this little picture over here and we'll try our best to understand what, say, in this case, cos 150 is. So cos 150, let's have a think about that. Well, cos 150, well, it's actually very similar. It's in this quadrant here. That's 150. And by definition, then, this here must be 30. Now, so we're basically saying we think it's something to do with cos 30. The only question is it plus or minus? And you look at the cast diagram, and you'll notice only sine is positive there, so this must be negative. So, well, cos 30, we know what that is. It's root 3 over 2, so this must be minus root 3 over 2. And I can't stress enough, really, what we're doing here. Notice we found the angle to the horizontal, and that we're going to keep doing it. We're going to keep doing that. So I'm going to delete my little picture of the angle, and then I'll use this diagram again for my third example. It says tan 570. Well, now, straight away I notice that's a big old angle. 360 plus what 570, that's an extra 210. So that basically means I go round all the way to 360 and I carry on going. Another 210. So that's a big old angle. So really you can kind of think of that and ignore the 360. And so I'm just going to write here, and the very first thing I'm going to say that's the same as tan of 210. Because going round 360 degrees on the cast diagram doesn't make any difference. You're still going to carry on doing it a further 210 to get up to 570. So where's 210 go? Well, 180 goes to there, and so 210's a little bit past there. And again, notice I want the angle to the horizontal, and that angle has got to be 30. So this is very much similar to tan of 30. And the only case that we now need to question is it positive or negative? And you look at the cast diagram, CAST, T is positive. So this is positive. So this then is the same as tan 30. It's a positive tan 30, which we now know is root 3 over 3. So we've got cos of 240 to do. Cos of 240 now on my newly clean diagram. 240, that's 180. I reckon it's there again. And again, 60 past. So this is like cos of 60. It's in the T quadrant, the third quadrant. So therefore it's negative because only tan is positive there. Cos of 60 is a half. This has got to be minus a half. And the last one is sine of 315. 315 is all the way around there. I reckon it is 45 degrees shy, and therefore it's the same as sine 45. And because it's in that quadrant, it's negative, and therefore it's minus root 2 over 2. Now look, it's a whirlwind tour of all things cast diagrammy there. My answers hopefully are agreed, and we'll have